All right, welcome back. We are looking at the top of page 15 of the definite integrals packet, and I wanted to end our discussion of using integration to help us with some physics questions on examples 20 and 21. Here we don't have a graph given to us of velocity, we have a function, a velocity function given to us, a cubic function. And it's some particle moving along a line. Let's call this line, since I didn't mention it, let's say it's a horizontal line. Meaning velocity could be positive, negative, or zero. If we get positive velocity, we'll say the object left or right is moving to the right. We'll call the right the positive direction. And if velocity comes out to be negative, we'll say the object is moving to the left at that time. Okay, what is keyword displacement of the particle on the time interval from 1 to 5? This question is cueing to us to set up our own definite integral from 1 to 5. And displacement is just your distance away from the starting point. It's your net distance traveled. So this can be set up as the definite integral from 1 to 5 seconds later of the velocity function, t to the third, I'll just recopy it, minus 20. Taken with respect to time. So all this just becomes a calculus question now. We can integrate this as if it was given to us out of context here, right? Why don't you go through and give this a try, and then feel free to pause the video and check back in with mine. I'll get t to the fourth over 4, right? I'm integrating as I go, minus 10, right? T to the third over 3, plus 29 t squared over 2, taking that one up a power. And then what's the integral of negative 20? We'll say negative 20t. And this gets evaluated from 1 to 5, right? So now, I mean, it's a longer function to integrate, but we'll just plug in 5, subtract what we get when we plug in 1. Feel free to use the calculator at this step. I'll try to simplify as I go. So 5 to the fourth, 625 divided by 4. Minus 10 times 5 to the third, so 10 times 125 is 1250 over 3. And then plus 29 times 5 squared, so times 25 over 2. And then 5 plugged in here, 20 times 5 is minus 100. Okay. Now we'll subtract what we get when we plug in the lower limit of integration. So 1 to the fourth over 4, 1/4, minus, 1 goes in here, 10 thirds times 1 cubed, so 10 thirds, plus 29 halves times 1, minus 20 times 1. This all gets calculated. I like it as an exact fraction. Decimal's okay too. It's going to be 32 thirds. And there's your displacement. We could put units on it. It says velocity is in feet per second, so we'll say the displacement is in feet. And the particle moves. Let's interpret it. The particle moves this distance, so 32 thirds of a foot, in which direction, right or left? Well, this displacement came out positive, so we'll say feet to the right. It could have taken twists and turns in between there, and we're about to see in the second example that it actually does. There is a change in direction, but displacement-wise, after from 1 to 5 seconds, it's moved this far away from the origin, from where it started. Now 21, this was my key point. This was what I wanted to get to. It says, what is the total distance traveled on that same exact interval from 1 to 5. We're not necessarily saying that the answer to 21 is going to be the same as the answer to 22, or to number 20. If I look at the original function, what is it? It's a velocity function that's an S-curve. It rises, falls, and then rises. So for a while, it could have up to 3 x-intercepts. And velocity could be above the x-axis during a portion, below the x-axis during a portion, and then above it again. Now, if I look, yikes, I think I'm messing things up there. If I look at, I actually conveniently put a graph for you underneath of this. So if you want to look down to the bottom here, where I've graphed out the velocity function, we see that there are 3 roots of it. Velocity is positive for a while. I'll just put a big plus sign in here for this shaded area. It takes a turn. So here's one root at 1, here's another root at 4, and then we're negative for a while as well. We are below the x-axis for a while between those. So this is v of t. The reason I drew this picture is because here we have to take this into account. Let me zoom this out a little bit so we can see both at once. We need to take into account that part of this distance is moving to the right and part of this distance is moving to the left. So for total distance traveled, here's where how I want you to set this up. This is a tougher question. It's still the integral of 1 to 5 from 1 to 5 of v of t, but it's the absolute value of v of t. I need to find a way to count this whole chunk as a positive displacement and this whole chunk as a positive displacement. And this picture is exactly how we're going to split this up. And we'll see these two separate parts in these two separate integrals we're about to add together. So how about just an integral of the time that the particle is moving in the positive direction? So from 1 to 4, v of t, just plain old v of t dt. This will be a positive area. The other integral, without putting a sign in between, is going to be the integral just from 4 to 5 seconds. So from 4 to 5 of v of t dt. If I put that without absolute values, this answer will come out to be negative. We are below the x-axis. I want to subtract the negative, thereby adding the two parts together. I should get two positive values. And let's see how this is going to come out. Now, we actually already did the work with the integration. I'm going to save myself some time and copy the integrals from up above. Integral from 1 to 4, I'll just glance up and see what I wrote in number 20, and I'll just evaluate it from 1 to 4. Remember, we integrated. We did t to the 4th over 4 in number 20, minus 10 t to the 3rd over 3, plus 29 t squared over 2, and then minus 20t. Gets evaluated from 1 to 4, giving me positive area, minus something that should come out negative. I apologize for the long recopy. Again, this problem just has a lot of terms. So same recopy. This is getting tedious. Minus 10t to the 3rd over 3 plus 29t squared over 2 minus 20t. And this is evaluated from 4 to 5. And this should do the trick. Now, I don't want to waste your time on the video here. I'd love for you to just pause and try the calculation. Using your calculator, plug in 4, subtract what you get when you plug in 1. Over here, plug in 5, subtract what you get when you plug in 4. Here are values for these two things to check. This whole thing will come out to the fraction 45/4. And then this whole thing, what we have to subtract, is going to come out to something negative, minus negative 7/12. So when all's said and done, after crunching a bunch of numbers, you get 71 over 6 feet, like that. Not something you're going to see coming up too often, but it is good to think about. The picture really saves me here, where when I'm trying to calculate total distance traveled, I can really split the problem up into two parts. Also, if you're writing things down, my birthday is right here, 7/12, July 12th. I love when it comes up in a math problem. Okay, please enjoy the rest of your day. Talk to you soon.